Yes or no? Samira, Anna. Okay, let's start this preparation of phenols. Just wait. Sania, is this your first class? Sania and Nimra.
Yes, sir.
Yes, sir.
Okay. Heather, are you there?
Yes, sir.
Heather, so if you are confused with the syllabus, always remember about the syllabus in upcoming exams will be the syllabus that we will cover from today and before Friday. That means whatever we are going to study today, that means in upcoming exams that will be held on Friday, alcohol will be there, aldehydes also will be there, and whatever we will study. Okay, from today's alcohol, aldehydes, and whatever we will be able to cover till the two next classes. Okay.
Okay, sir. Thank you, sir.
Okay. If anyone have any confusion, please ask me. Okay, so we are going for preparation of phenols. So see, this preparation of phenols, as I told you to please do revise at home before the class, because these reactions are repeated as you have substitution reaction, nucleophilic substitution reaction in haloarenes and haloalkanes and haloarenes. This is your chlorobenzene, and if you are going to react this with the sodium hydroxide at 623 Kelvin and 300 atm pressure, then what will happen? This chlorine will be replaced by O negative Na positive. This has a name, phenoxide ion, or we can call it phenoxide, sodium phenoxide. And if you are going to again react this with HCl or acid, any acid, then this Na plus will be replaced by H and you will get phenol. So it's very easy, phenol. Now, as you can see, this process has a name that we call Dawes process. Dawes process. So this is the first method to prepare basically the phenol. The second method, this is from chlorobenzene or from to prepare the phenol from sulfonic acid, or we can call it benzene sulfonic acid. It's also very easy. Benzene sulfonic acid. So if first of all you are going to prepare benzene sulfonic acid, and this will be prepared from this benzene. If you are going to react this benzene with oleum, oleum has a formula H2S2O7, or we call it fused sulfuric acid, then you will be getting SO3H, benzene sulfonic acid. After getting this, you are going to react this with Na oxide ion. This will be the first reaction, and after the first reaction, you are going to react this with H plus or acid in the second step. Then this SO3H will be directly converted into phenol. So this is the second method to prepare phenol. If you want to write a write a product or intermediate between these two, that means if you are going to react this benzene sulfonic acid with NaOH, you will be getting O negative, Na positive, O negative and Na positive. Then after applying this H plus, then you will be getting this. Okay. So please do write it. Can I change the slide? Abhinav, Alia, Hiram, Nidra, Samira, Soni.
Dhamsa.
Okay. Now see, the next preparation is from diazonium, from diazonium salt, from diazonium salt. So basically, we are going to prepare first diazonium salt, and how we are going to prepare this reaction you have also covered in the first chapter. So as you can see, this is your aniline or benzenamine, you can call it. Aniline now is treated as IUPAC. So if you are going to react this aniline with nitrous acid that means NaNO2 in the presence of HCl, and this reaction should be carried at in cold, that means 0 to 5 degrees centigrade, then you will be directly getting the benzene diazonium chloride, which means diazonium salt, N2 plus Cl minus. And after getting this BDS, that means BDS means benzene diazonium salt. After getting this benzene diazonium salt, you are going to react this with H2O or hydrolyze it. So this N2Cl minus will be replaced by hydroxyl group of H2O, and you will be getting phenol. So this is the third preparation of the alcohol, phenol. And after that, after this, we have the next preparation of phenol, which is very important. And there has been a question that is asked in your previous years of NEET, and that is from cumene. Can I change the slide?
Yes, sir.
Okay. Now, the fourth preparation, and it is the last preparation of phenol, and this is from cumene. Cumene is a common name, and I'm gonna write the structure of this. This is your cumene. Benzene it has, and then there is CH, and then CH3 is here, and again CH3 is here. Now, first of all, you are going to react this with O2, this cumene. Then this between this carbon and hydrogen, two oxygen will be introduced. That means oxidation of cumene took place. Oxidation of cumene took place, as you can see, COO peroxide form. Its name is basically cumene hydroperoxide. And after this, you are going to hydrolyze it in the presence of acid. You know what will happen? This total group will be eliminated in the form of ketone. So this will be your byproduct. You can say CH3, C double bond O, CH3 propanol, which is a byproduct. And this OH will be directly attacked with on the benzene ring, and then it will form your phenol. So one of the question from PYQ in NEET that has been asked is the intermediate. This is your intermediate. This is your intermediate. So they asked, the reaction was given like this, and here it has been written A, and everything was given except this. And they asked, what is this A? Is that clear? This is your ketone, propanol. This is your main product because we were preparing phenol. So just let me know when you are done with this. Again, the chemical reaction of this phenol will be repeated. Like we had covered already this reaction in the previous chapter of aromatic hydrocarbon. the electrophilic substitution reaction. We did nitration, we did halogenation, we also did sulfonation, we also did Friedel-Crafts alkylation, Friedel-Crafts acylation, each and everything. So we are just going to repeat this. Can I change the slide?
Yes, sir.
Okay, thank you. Now, as you can see, the chemical reaction. And in this, first we are going to study about the electrophilic substitution. First, we are going to do electrophilic substitution. So in electrophilic substitution, first is nitration. So you have to recognize what reagent we are going to use in this nitration, or to do nitration, which reagent we are going to use. So it's very easy. First of all, you can see this is your phenol, since we are studying the chemical reaction of phenol. So in phenol, if you are going to use dilute HNO3, dilute HNO3. So due to this reagent dilute HNO3, that means HNO3 in the presence of more amount of water, there will be generation of an electrophile, that is NO2 plus. Can anyone tell me what is the name of this NO2 plus? Can anyone tell me what is the name of this NO2 plus? Samaira, Iram, Heather, Sania, Nimra, Alia. I'm asking this question only because I have already told you in the previous classes. This NO2 plus is an electrophile and it has a name, nitronium ion. Nitronium. Generally, students they confuses and they pick the mark for nitrosonium. This is not your nitrosonium. This is your nitronium. So as you can see, OH is plus M. OH is plus M. And in hydrocarbon, I told you, there is two types of resonance. You can see this is your minus M and plus M. Whenever plus M is there, this will be ortho and para directing. And whenever in benzene ring, minus M group will be added or attached, then this is your meta directing. Meta directing. So since OH is a plus M group, plus M, that means it will donate electron to the benzene ring. That's why it is plus M. And plus M is ortho and para directing. So this NO2 plus will be directing direct attack on ortho first, and then it will also direct attack on para. Because ortho and para is electron rich density or electron rich area. So this electrophile, which is having deficiency of electron, will be attacking at that center or at that place which is having more electron. Since this plus M is ortho and para directing, that means ortho and para will have rich electron density. That's why it attacked on ortho and para, not matter. Now my next question is, which one is major and which one is minor? We decide this majority, the one which is more stable, your minor. So can anyone tell me, ortho will be major or para will be major? Tell me.
Ortho.
This is very easy question. Who said ortho? No, no, no.
You said the more stable one will be in minor.
Generally, para is major. This is your major, and this is your minor. Because here you can see hydrogen bonding will be intramolecular hydrogen bonding in ortho. So generally students think that if hydrogen bonding is there, that means it is more stable. But fact is that this is your intramolecular hydrogen bonding. That means uh, uh, that means uh, the hydrogen bonding inside the molecule, that is intramolecular hydrogen bonding, but in para there is intermolecular hydrogen bonding. Intermolecular hydrogen bonding. So if intermolecular hydrogen bonding will be there, you can see this is your intermolecular. I'm going to show you. This is your at para position. This is your OH. There will be another molecule of this para. There is another molecule of this para nitrophenol, and there will be hydrogen bonding between this. So this is between two molecules. It is called intermolecular hydrogen bonding, and between same molecule, that means basically inside the molecule, if hydrogen bonding is there, that is your intramolecular hydrogen bonding. As this, due to this hydrogen bonding, two molecules associated to become one molecule, due to which molecular weight increases, and due to increase in molecular weight, van der Waals force of attraction also increases. Van der Waals force of attraction also increases. That means it becomes more and more stable. Which one? Para one is more stable due to this intermolecular hydrogen bonding. It is also very important to note that this will be your more volatile. This will be your more volatile, and this will be your less volatile. We can also write boiling point lesser. That means ortho will have boiling point lesser, and this will have more boiling point. It's all are connected. If you will think like this, first of all, ortho and para will be major product. Why para will be major product? It is more stable. Why it is more stable when they both having hydrogen bonding? Because in para intermolecular hydrogen bonding is there, and in ortho intramolecular hydrogen bonding is there. So what is the difference between them? So due to intermolecular hydrogen bonding in para, the two molecules combine to form a single molecule, which means the molecular weight increases of the molecule, and the van der Waals force of attraction increases, and hence they will be more stable. That's why they are measured. Now, since they are more stable, they will be less volatile, and the one which is less stable will be heated, it will be converted into vapor. The one which is less volatile, it will need more and more energy to convert it into the vapor form, and the one which is more volatile, it will be easily vaporized. That's why ortho will have lesser boiling point and para will have greater boiling point. Is that clear, everyone?
Yes, sir.
Okay, very good. Arpit, how is your preparation going?
Sir, it is going good.
Good, very good. So, can we move to the next part? So, always remember that about organic and inorganic. If you are going to command on your NCRT, it will be very helpful to do almost 90% of the question from organic and almost more than 90% of the questions from inorganic.
Sir, what is the
It
weightage
won't
of
be out
organic?
of your NC. Weight is generally it varies, but you can think of, if you have 45 questions, so you will get almost what do we say, 15, 15 to 18. Arpit,
Okay, sir.
yeah, I
And
just
sir, how much from inorganic, sir?
inorganic generally is lesser in quantity, but we have uh, for the wait a minute, I analyzed uh, on previous Sunday, and from the last 5 years, it is almost that varies. Sometimes it is 13. On an average, it is 14 to 16. 13 to 16, you can call it.
Okay, sir.
Okay. Can I change the slide? And the rest is from physical chemistry. Can I change the slide?
Yes, sir.
Yes, sir.
Okay. Now see, if you are going to treat this phenol with dilute HNO3, you will be getting orthonitrophenol and paranitrophenol. But if you are going to treat this phenol with concentrated HNO3, with concentrated HNO3, that means there will be the concentration of NO2 plus will be higher, and hence NO2 will be attacking at ortho, NO2 will be attacking at para, and NO2 will be attacking on ortho again. What do you mean by this concentrated HNO3? So as you know that in concentrated HNO3, the amount of HNO3 will be very, very high. That's why the NO2 plus that will be generating from this that will be generating from this reagent will be more, and it will attack at orthopara 6 trinitrophenol, and it has a common name which is quite famous in organic chemistry, and that is your picric acid. Always remember this name. Some common name are very, very important, like salicylic acid. In the previous class we discussed salicylaldehyde, that will come, and then this is picric acid, which is very, very important. Can you change the slide?
Yes, sir.
Just wait a minute. Okay. I'm gonna give you a question. Just wait.
Sir, done.
No, very good. Okay. Okay. After nitration, there is halogenation. From the name, you can think of halogenation. That means addition of halogen is taking place. So in phenol, which reagent we are going to use that so that halogenation will take place? So for the halogenation, you are going to use Br2 in the presence of CH2, carbon disulfide, at 273 Kelvin. So due to this reagent, there will be generation of an electrophile, that is Br positive. That is Br positive. And since this is your plus M, are you the new students? Are you aware of this plus M? Yes or no?
Sir, what?
Just let me know, because it will be plus M and minus M. Sania and Nimra, you also please do answer me. If you don't know this, this will be bounce.
Plus
Okay.
M means ortho and meta directing group.
Yeah, that's good. And minus M?
Para directing group.
Very good. Nimra and Arpit, are you aware of this plus M?
No, sir. So can you explain?
Okay, actually, Arpit, will you be able to do the write the resonating structure of this phenol? Yes or no?
Yes, sir.
So if you are going to write the resonating structure, so this will move to this and this will move to this, and you can see there will be negative charge on ortho with respect to this OH group. Yes or no?
Yes, sir.
And after that, if you will do, I'm not going to write all the resonating structure. If after that, if you are going to do the next, you can see the negative charge moves to this. Yes or no?
Yes, sir.
This is your para position. After that, if you are going to do, the negative charge shifted to again ortho position with respect to this. Yes or no?
Yes, sir.
right? Now just think that if this reagent you are going to use, there will be generation of an electrophile that is Br positive. What do you think? This Br positive, which is electrophile, that means having deficiency of electron, it will either attack at this position, it will either attack at this position, or it will either attack at this position, right? Because it is the electron rich density site. Yes or no?
Sir, then try substitution will occur, I guess.
Try. What did you say just?
Sir, try substitution, sir.
No,
So
no,
BR.
not try substitution. I'm just giving you option right now. Since Br2 in the presence of CS2 will only generate, so there will be no try substitution. It will either attack here, it will either attack here. This attacking and this attacking will be similar because both are ortho position. So you will be getting two product. You will be getting two product with respect to OH. This will be your ortho. If you are going to use Br at here or here, they will be both same because they are ortho position, and it will either attack on this para position. Yes or no?
Yes, sir.
So try substitution not take place here because due to this reagent, you will get only one electrophile. So it will attack only at one position. Since this and this is different, so you will be getting two products, one at ortho, which is minor, and one at para, which is major. Why this is minor? Because Br has a larger structure geometry, and this also have something, so there will be repulsion. That's why it is less stable, and hence minor product, and this will be your major product. Is that clear, everyone?
Yes, sir.
Yes, sir.
But if you are going to use the reagent, please be focused here. If you are going to use this or 3Br2, that means very high level of very high concentration of Br. So there will be generation of a lot of bromine, Br plus electrophile. So this will be attacking at whatever place is there, whatever site is suitable for them. So you saw that there will be suitable site at this because there was negative formation at ortho, at para, and again at Br. So this will be your 2,4,6 tribromo phenol. So again, I'm going to repeat with the reagent of Br2 in CS2, you generated only one Br plus. So either it will go at ortho or either it will go at para because that is electron rich density site. But when you are going to use bromine water, this is also sometimes Br2 plus of a lot of Br plus, and Br plus is an electrophile. So this will attack at that position where electron density is rich. So you can see electron density at ortho rich, electron density at para rich, and we have a lot of Br positive. So it will be attacking at that site where electron density is high. So this will be the product. Is that clear?
Yes, sir.
Can I change the slide?
Yes.
Everyone. And the new students, Sania and Nimra and Arpit, the coordinator will send you the link for the previous classes. Please do go through that, and then we will have backup class. Okay, can I change the slide?
Yes, sir.
Okay, thank you. Now the next in this chapter is another name reaction, that is Kolbe's reaction. So if you are going for Kolbe's reaction, see what we do basically, we are going to react this phenol with NaOH. whenever you are going to do this, you know that this is your base and this is your acid. What will happen? Salt will be formation of salt will take place. Phenoxide ion or sodium phenoxide salt formation will take place. After this, you are going to react. First of all, you are going to react this with CO2, and in the second step, you are going to react with H plus. So this CO2 will be attaching with CO at para position or ortho position, you can say, not para, ortho, carboxylic acid, and this Na plus will be removed, replaced by H. So there will be hydrogen, and this compound is known as salicylic. What is this? We already did it. Salicylic acid.
Salicylic acid.
Salicylic acid. If there will be CHO, then its name will be salicyldehyde.
Salicyldehyde.
And if you are going to write the IUPAC name of this, it will have a name, 2-hydroxybenzoic acid. So you have to be prepared for each and everything here, like what is the reagent we are using, what is the what we say, what is the intermediate form, everything. They can ask anything. Can we go for the next?
Yes, sir.
So the next is quite important, and that is known as your Riemel-Tiemann reaction. So I'm going to show you the Riemel-Tiemann reaction. So see, phenol is there. And if you are going to react this with chloroform, CHCl3, in the presence of aqueous NaOH, NaOH is there. So what you need to do, it's very simple. There will be formation of an intermediate, and it is basically O negative, Na positive. And due to this chloroform, there will be formation of this as well. This is your intermediate. Now, what you are going to do first, I'm going to explain this here. First, you are going to use again NaOH. Again NaOH you are going to use. So what will happen? This Cl will be replaced by, OH. Both the Cl will be replaced by OH with the help of sodium hydroxide. And you know that one carbon cannot hold two hydroxy groups. So there will be removal of H2O. So there will be removal of H2O, and you will be getting, you can see CHO. After this, you are going to just pass this through H plus, and you will be getting this H plus will replace this Na. So this is the main product that is known as salicylaldehyde. Salicylaldehyde. So this was a little explanation of this. I'm going to write ahead. If you're going to react this with NaOH, first you will be getting directly, I'm going to write here, this is your O negative Na positive, and then this will be converted into CHO. After this, you are going to react this with acid, and you will be getting this salicylaldehyde. So this is how the reaction took place. You can either write the above one, which is in a straight line, or you can go further down. How CHO comes, that's what I explained here.
Done, sir.
Okay. Now the next reaction is basically your reaction with zinc. Reaction with zinc. That means if you are going to react this phenol with zinc, this zinc will be acting as a reducing agent, and what it will do, it will take oxygen from the phenol and it will be out. So this reaction is what we get benzene, and this is also a reaction to preparation for the preparation of benzene from phenol. This is your phenol. If you are going to treat zinc with phenol or phenol with zinc, the zinc will take oxygen from the phenol and it will be reduced to benzene. And then
So
comes the, yes,
here we have to use the zinc dust, right?
yeah, zinc dust or zinc you can take, right. That means
Okay, sir.
zinc, or you can write zinc dust too. Okay,
Yes, sir.
not a problem. Okay. Oxidation. If you are going to oxidize this phenol, it will be converted into benzoquinone. This is your phenol, and if you want to oxidize it, see what will happen. We are going to use Na2Cr2O7, that means sodium dichromate, in the presence of H2SO4. So this will be oxidizes into benzoquinone. This has a common name, benzoquinone. So it's very, very easy. Let me know when you are done with this.
Done, sir.
Okay. So here our phenol is completed. Now we are going for ethers. So you know ether is ROR. So first of all, if I'm gonna give you a question, write the IUPAC name of this. Can you do this? What will be the name of this compound? Ether has a IUPAC name. I'm gonna write it in general form. Alkoxy alkane. Alk is for methoxymethane. Very good. Who is this? Very good. So as you know that this alk part is the number of carbon, this alk part is the number of carbon. Oxy comes with, this is for branch or substituent, branch or substituent. And this is your N is for main parent chain, main parent chain. Very good. Now, as you can see, we need to decide how the one which is lesser in number of carbon is your substituent, and since here both will have same number of carbon, both have same number of carbon, so you can take any one of them, as this will have a name methoxy and this will have a name. Total name or IUPAC name is this. So can anyone do this? First, you need to count the number of carbon both sides. So you can see this is your 1, 2, and this is your 1, 2, 3. So this will be your substituent. So if this is your substituent, you are going to add oxy at the end. So 2 carbon, that means eth, and since it is a substituent, I'm going to write oxy. So its name will be ethoxy, and this is your parent chain. So its name is alk, that means prop. And since all are singly bonded, so propane. So the name is quite easy, right? Writing the IUPAC name of this ether is quite easy. Can you change the slide? Nimra, Sumaira, Iram, Arpita, Alia, Anna.
Yes, sir.
Okay. Now see, methods of preparation of ether. There are two methods. The first one is similar to the dehydration of alcohol. Dehydration of alcohol is for the formation of alkene. When we do, there is slightly difference in condition. If you have this CH3, CH2, OH, you know that if you are going to use, this is your ethanol, and if you are going to use H2SO4 at 443 Kelvin, and if you are going to use H2SO4 at 413 Kelvin, if you are going to use this at 443 Kelvin, then elimination of water, dehydration will be taking place. Dehydration will be taking place, and this will be formed CH2, double bond CH2. We did the mechanism. OH from here and H from adjacent carbon will be removed and alkene will be formed. But when we are going to use at 443 Kelvin, this will be written as CH3, CH2, O, and then again this will be repeated in its image form. And this is what we get, ethoxyethane. So in the formation of alkene only we use 1 mole of CH3, CH2OH, and in the formation of this ether we need 2 mole of CH3, CH2OH. Is that clear?
Yes, sir.
Sir,
Yes.
are mechanism important for these questions?
Mechanism is important only for the whenever there will be formation of carbocation. Basically, we need to know the mechanism because of its intermediate, what intermediate formation is taking place. Because if intermediate is like carbocation, then we should go for the rearrangement. Are you getting my point? If you are going
Yes,
to
sir.
use this, there is OH. So if you are going to remove this in the mechanism, you will see there will be uh, carbocation formation. So we should rearrange this. This is the reactant. So after removing OH, you got the positive sign here, which is 2 degree. So you have to look around this. On the right hand side, if you are going to move this positive to this side, it will be 1 degree, which is less stable, so it is not possible. But if you are going to move on the left hand side, there will be positive and it is 3 degree, so it is more stable. So this will be the intermediate for major product. Are you getting my point?
Yes, sir.
But if you look in this chapter, if you look at the mechanism that is given in NCERT, there is no formation of carbocation. That's why I just skip it. Okay,
Okay, sir.
this is not that. So this is the first method to prepare ether. Can we move to the next?
Yes, sir.
Okay. Now the next is quite important, and it has a name that comes under name reaction, and its name is Williamson synthesis. Williamson synthesis, and this we use to prepare ether. So basically, if you have an alkyl halide and this is your ROO and Na positive, and I'm gonna write negative here. So there will be substitution reaction. There will be nucleophilic substitution reaction. Basically, this Williamson synthesis reaction occurs with the mechanism of SN2. And you know that as in SN2, 3 degree, 2 degree, 1 degree is not the reactivity. In SN2, 1 degree, 2 degree, 3 degree reactivity takes place. Yes or no? I just revised this. In SN2, the reactivity for prime alkyl halide is 1 degree, 2 degree, 3 degree. Yes or no?
Yes, sir.
Yes, sir.
So what you need to do, just replace this. This will have negative, this will have positive. So you can see this negative will be going with this positive, and you will be getting ROR, and this positive with this negative, and then you will be getting a salt that is NaX. Are you getting my point?
Yes.
Since this is your nucleophilic substitution bimolecular reaction, always remember that this Rx, only I'm talking about the alkyl halide part, cannot be 3 degree. If it is 3 degree alkyl halide, then elimination compete over substitution. Elimination compete over substitution. As you know that in SN2, 1 degree is very reactive, then 2 degree, then 3 degree. Due to the steric hindrance, 3 degree will be not taking place here, and elimination will compete over the substitution. Only I'm talking about Rx. This can be 1 degree, 2 degree, 3 degree, anything. But if you want to do the reaction fast, then this Rx should be primary. This should be primary and can be secondary, but cannot be tertiary. I'm going to show you with the help of an example. I'm going to take this alkoxide part first. So it can be like this, and then this is your O, and this is your O negative, and if you are going to react this CH3Br, so you can see the alkyl part is what alkyl part is your primary. This will move and this will be attacking here, and you will be getting CH3, CCH3, and then again CH3, and then O, and after O there will be CH3, and NABR will be the byproduct. But if you are going to have the second tertiary alkyl halide, I'm going to show you. This is your tertiary alkyl halide, CH3, CH3, and this is your Br. And if you are going to use this O, O, and this CH3, so as you can see, the halide is tertiary, then elimination will compete over substitution. Just wait a minute. Okay. Elimination will compete over substitution, and here what will happen first? So as you can see, this will have negative, this will have positive, so they both combine to form NABR. This is your byproduct, NABR. Now what will happen? Since Br is eliminated, one of the hydrogen from any adjacent carbon will be eliminated, and this is what you will get. C double bond, now hydrogen is not there, CH2, and then CH3. What I just did, Br is eliminated, Br will live. It is a living group, and one of the hydrogen will also be eliminated. So there will be double bond between this adjacent carbon, and alkene formation take place. Now the hydrogen which goes from here will combine with oxygen to form alcohol CH3, and Na will go with Br to form this byproduct. There are two byproducts, and this is your main product. And as you can see, when you are going to take tertiary alkyl halide, you will be getting an alkene instead of ether. Okay. Is that clear?
Yes, sir.
Okay. So for the better yield or for better production of alkyl halide, you should take primary alkyl halide instead of secondary. And if you are going to take tertiary, then you will not get ether, you will get alkene. Can I change the slide?
Yes, sir.
No. The chemical reaction again, the chemical reaction. Again, the reaction will be repeated. That's why I told you to study about this chapter at home, because you just passed the class 12. So we will be able to do question instead of this quick revision. Chemical reaction of ether. So I'm going to just ask you, can anyone tell me this ether connected to benzene, which has a common name, which has IUPAC name methoxybenzene, or common name anisole. It's also very important, anisole. So can anyone tell me what is the effect of this OCH3, plus M or minus M? Can anyone tell me? What is the effect of resonance for this OCH3? Okay, no answer from anyone. Heather, Avino, Alia, Anna, Samira. Uh, if you don't know, please do let me know. If you have this phenol, as I told you, this will give, that's why it will have plus M. What do you think about OCH3? Will it have plus M or minus M? If you don't know, you can respond.
It will take away the electron.
It is
Yeah.
electron withdrawing.
Electron withdrawing. See, I'm going to give you a best trick to calculate this, to not calculate, to find out whether it is plus M or minus M. So if anyone which is having lone pair, any group which is having lone pair, and it is singly bonded, as you can see, and any group which is having lone pair, which is doubly bonded. So any group which is having lone pair and singly bonded, it will donate, and that's why this group will be plus M. And you can see doubly bonded and it has a lone pair, it will act as minus M. So in case of this OCH, you can see it has lone pair and singly bonded, that's why it donated and it acts as plus M. Again, this is O and it has lone pair and singly bonded, so it will also donate. So if you are going for aldehyde, you can see this is having lone pair and doubly bonded, so it attract or withdraw electron from the ring. Are you getting my point?
Yes, sir.
So this concept I already taught you in hydrocarbon, aromatic hydrocarbon. You have to be careful, because if any questions comes like this, what is the effect of resonance or mesomeric effect, plus M or minus M, you are going to decide in this way. So can anyone tell me this NO2 will have plus M or minus M? This group will be plus M or minus M?
Minus M.
Minus M, because this has a lone pair, so it will withdraw, and this is minus M. Okay, NO2 also minus M. Can anyone tell me about this chlorobenzene? Will it act as minus M or plus M?
Plus M.
Plus M.
Yes, can.
Since this is your single bond, so it will be acting as plus M. Very good. Now I'm gonna give you question. Electrophilic, again the reaction repeats itself, electrophilic substitution reaction. This is your halogenation. You can do it easily. I just repeated this reaction in the starting of the lecture. This is your anisole. And if you are going to react this with Br2 in the presence of FeCl3, this is this reagent will generate Br plus. What do you think? What will be the product? This Br plus will be attacking at two places. One at para and another at ortho. Which one will be the, you know that since this is your plus M and plus M is ortho and para directing. So which one will be the major product, ortho or para?
Para.
So this will be your major and this will be your minor. Can we go for the next?
Yes.
Okay. So see, the next reaction is known as Friedel graph. We already did in the previous chapter. So this is your anisole. And Friedel-Crafts reaction is of two types. One is Friedel-Crafts alkylation and another is Friedel-Crafts acylation. We also did this reaction in the aromatic hydrocarbon. What was the reagent that we used? RX in the presence of anhydride AlCl3. See what will happen here. Due to this reagent, this leaving group will go and generate an electrophile that is R plus. So this R plus will be attached at two positions because OCH3 is plus M. So it will be attacking at ortho and it will be attacking at para only. Now the next reaction is from this, which is acyl halide RC double bond OX and in the presence of anhydride AlCl3 again. And you can see with this, you will be getting an electrophile that is RC double bond O positive. Basically, this leaving group will leave and there will be positive charge here. So this C double bond O positive will be attacking at ortho C double bond O CH3 R is there and para again. Positive side C double bond O up. So this is known as, since alkyl is here, so this reaction is basically Friedel-Crafts alkylation. Alkyl part is there, and this is your acyl halide. So this reaction is known as Friedel-Crafts acylation. So it's very easy. The electrophilic substitution reaction in organic chemistry is very, very easy. Please do write it. Are you done with this?
Yes, sir, done.
Okay. The next electrophilic substitution reaction is your nitration. And you know, for nitration, we use HNO3. in the presence of H2SO4. So this is your phenol, not phenol, anisole. And if you are going to use this HNO3 in the presence of H2SO, due to this reagent, there will be formation of an electrophile, that is NO2 plus, which has a name nitronium. So this nitronium NO2 will be attacking at two positions. One is at ortho and another is at para. So this will be your major and this will be your minor. So it's very easy.
Done, sir.
Done. Very good. Wait a minute. I'm gonna share a screen. This chapter is completed here. I'm just gonna give you some question. So first you are going to do the question number 20. HBr reacts fastest with which one? If you are unable to do anything or you are unable to think anything about the question, just let me know. I'll explain. This is the wrong answer. I'm going to explain. HBr reacts fast with 2-methyl propanol. So I'm gonna propane 1-ol. So this will be the structure. 2-methyl. Wait a minute. Yeah, this will be the structure for the first one. For the second option, this will be the structure. And for the third option, this will be the structure. And for the fourth option, this will be the structure. Now, when HBr is going to react, first OH will be eliminated. So there will be formation of secondary carbocation, and there will be formation of primary carbocation. In the third option, you can see secondary carbocation. This is your primary carbocation, and here, if you are going to remove, again you will get primary carbocation. But if you are going to remove this for OH from the second option, you will be getting tertiary carbocation, and you know that tertiary carbocation is more stable than secondary and primary. So fastest will go with B. 2-methyl propane 2-ol. So you are going to remove OH and put positive charge on carbon. So as you can see, this is your tertiary. That's why. Are you getting my point? Samaira, Iram, Heather, Arpit,
Yes, sir.
Avino,
Yes,
Sania,
sir.
Neha. Okay. Now you are going to do the question number 21. The compound which reacts fastest with Lucas reagent at room temperature. In the previous class, I discussed about Lucas reagent. Lucas reagent, do you remember what is Lucas reagent? Yes or no?
Yes.
Lucas reagent is basically concentrated HCl, very good, plus ZnCl. And there is formation of carbocation again. So you know that which carbocation will be the most stable, 3 degree. Just let me check. Yeah, very good, very good. This is Arpit and Heather. Very good. Samara, D. Yeah, it is D because Lucas reagent in this, if you go by the mechanism, I already told you there will be formation of carbocation and you have to choose this. This is your butane one all. So if you are going to remove this, there will be formation of 1 degree carbocation. Okay, by the way, I just wrote the wrong this, but the concept is right. I took butanol, but here it is propanol. So the structure is wrong, but the concept is right. I'm gonna show you. I just focused. 2-methyl propanol will have a structure this, and this will have a structure this. So again, if you are going to remove this, there will be formation of tertiary. Now come to the 21 question number. There will be formation of 1 degree. There will be formation of 2 degree. There will be formation of 2 degree. Again, there will be formation of 1 degree, and there will be formation of tertiary. So the right answer is D. Alia, are you able to understand this? Yes or no? Okay. Question number 22, which is also the preparation of alcohol, which is also the preparation of alcohol. If you remember or if you know the concept, please do question number 20. Very good. Who is this? Arpit. Very good. This reaction is basically a hydroboration
Hydroboration.
oxidation. If you are going to react this, we do this reaction B2H6 in the presence of THF, tetrahydrofuran. And in the second step, we are going to use H2A2 in the presence of base. Then there will be formation of a primary alcohol. And I already told you in hydroboration oxidation, anti-Markovnikov take place. Anti-Markovnikov. That means primary alcohol. So C will be your answer. Very good, Samira. Can we move to the next part? Everyone is getting it? Yes or no, Heather?
Yes, sir.
Yes, sir.
Abhino? Okay, again, this Lucas reagent is quite important. See for yourself. Lucas reagent is, I just write the name of the Lucas reagent. What is it? It is concentrated HCl and anhydrous ZnCl2. This should be dried. Always remember that, not hydrous. See the confused, you will be confused with the statement if you have any doubt in your answer. Concentrated HCl and anhydrous ZnCl2. Concentrated HCl and hydrous, not hydrous. It should be dried up. So the answer is A. Okay. Now go for the question number 24. I'm not going to show you the option. You are going to tell me the A part. What is it? As I already told you, there is a question from the preparation of phenol, preparation of phenol from cumene, and they ask you the intermediate. Any answer?
Sir, which question are we doing? Sir, I lost the connection.
Question number 24.
Can you show the options?
Yeah, I told you to. I'm not gonna show you the option. No, this is wrong. Carboxylic acid. Oh, okay. See the option. Oh, wait a minute. This is your BCD option. A option was there. One of the option was there. Now your B, C, D. Yeah, it is Iram. Very good. So if you are going to react this cumene, if you remember, this is your cumene. CH3 here, CH3 here. And you are going to react this O2. What I told you. I told you that peroxide will be formed in this. So what will be our answer? Answer will be B. Our answer will be. Can we move to the next part? Just wait a minute, please. Okay. Question number 25. If you know the mechanism only, you can then you can do it. I'm going to explain it. See, this is your haloform reaction. What it is? This is your haloform reaction. So this NaOH react with this CHCl3 and you will be getting CCl3 negative and this H will be removed. So H will be going in the form of H plus and OH will be going from here O negative and there will be formation of H2. Now see this CCl minus 3 will be, there will be elimination of alpha elimination will be there. Cl minus will be removed. So what we will get, not Cl minus, only Cl will be removed. So what we will get CCl2 dot. This is known as dichlorocarbon. So you have to remember that in the mechanism of this haloform, you got dichlorocarbene and the answer will be C. So the mechanism only important only because of its intermediate and the reagent. When the reagent combine together, what they form, what is the name of the intermediate? So that's why they are important only. So here, always remember that in haloform, this reaction, not this is not chloroform here. Chloroform and react with NaOH, you will be getting CCl. Okay. This is not your haloform reaction because haloform reaction is there. In haloform reaction, we have I2 there or Br2. So when
This is
chloro,
Rivatimine.
What did you say?
This is
Yeah,
rabbit
this is your
amylase.
Rimertimen. Yes, exactly. This is your Rimertimen. So Rimertimen, the intermediate is dichlorocarbon, not haloform. I just got confused with CaCl3. Chloroform is there, that's why I told haloform. So this is your Rimertimen. So please do remember this. This is your haloform reaction. NaOI. So please do it. First of all, you are going to write a compound with this formula. Is found to react with NaOI produced by Y with NaOH, and it's a yellow precipitate with characteristics smell. So just let me know if you are going to draw an structure or write an structure for this, and since this is your haloform reaction, so first of all you need to know what is haloform reaction. So always remember that haloform reaction react with methyl ketone. That means the ketone in which after adjacent to this C double bond O, there must be a CH3 group. Only that ketone will show haloform reaction. Another which is very important is your alcohol also show haloform reaction in this way. In this way, the OH group to which alcohol is connected adjacent to this alcoholic group, there should be CH3, and also there should be this you should know CH3 CH2OH. Ethanol also show what they show haloform reaction. So I'm going to write a structure with the help of this, and you can see the structure will be this, and then CHOH and CH3. So you can see this CHOH adjacent to this CH3 is there. And now what you are going to do, you are going to react this with NaOI, or you can write NaOH in the presence of I2. This will give this basically. So you will be getting, this will be oxidized basically. C double bond O, and then here comes O negative, Na positive. And this part will be iodoform CHI3. And this is very important to note that this is yellow PPT. The color is yellow PPT. So the answer that you will get is what? This is your answer. D. It's very easy to omit since you know it is haloform reaction. OH is here and adjacent to this there is no CH3, so this will not be your answer. OH is here and adjacent to this there is CH2, CH3 is not there, this is also not your answer. OH is here adjacent to this is not your CH3, so this will not be your answer. OH is here and adjacent to this there is no CH3, but on the right hand side there is CH3, so this will be your answer. Simple. Okay. Can we move to the next part? Can I change the slide?
Yes, sir.
Okay. Come to the next question, that is question number 27. Please do it. Think about it, then let me know.
So can you scroll down a little for the option?
Okay, everyone is, this is your option. This is your reaction. and you need to tell me P and then Q and R. You should do the reaction instead of looking at the option first. Okay, I'm going to explain this. Here, this is your alkylation. Alkyl halide with anhydrous Cl. So if this Cl will go, there will be formation of carbocation, CH3, CH2, CH2 plus. Now you can see this is your 1 degree carbocation. So whenever there will be formation of carbocation, you are going to check whether a rearrangement is possible or not. So you can see if you are going to remove 1,2 hydride shift, so there will be formation of 2 degree carbocation. So this is good. So now this is your benzene. You can create a negative charge. You are going to remove one of the hydrogen is there. Hydrogen will take hydrogen will give electron to the carbon, and it will be out in the in proton form. So there will be negative. So there will be bonding between. So it forms cumene. If you are look at it, if you look at it carefully, it forms cumene. This is your cumene. Now you are going to react this with O2 first. So if you are going to react this with O2 first, what will happen? There will be formation of peroxide. Oxygen will be added between hydrogen and carbon. So this is your CH3, this is your CH. And after this, you are going to do the hydrolysis in the presence of acid and heat it. What will happen? I told you that this will be eliminated. That means propanol will form the byproduct, that is your R. And then Q, you can see this phenol is. So what is your answer? P is basically, let me show you this. And Q is what? Wait a minute, it's also wrong. This is your P, this is your Q, phenol, and this is your R. I draw this is wrong because R is ketone and here it is given 2 degree alcohol. That's why it is wrong. Is that clear, everyone? Samira, Hiram,
Yes, sir.
okay, Anna, Sania, Amino, Alia, Heather. So this is it for today's class. Now I'm gonna give you some homework for yourself. Since you just passed class 12, so you are, I think, I assume that everyone is aware of aldehyde, ketones, and carboxylic acid That means you know the basic preparation. So you are going to do all the preparation. I will directly give the question and come to the important chemical reaction on, so that we will be able to do a lot of questions. Important chemical reaction I will do here, like aldol, canizaro,